All right. You are welcome to today's class. Today we want to look at bit fields. Now, what are bit fields? Bit fields are variables inside a structure that have defined number of bits assigned to them. Now, why do we need to do this? We need space, right? And for embedded devices, it's very important that we use this concept. Now, when you define something like this int a, right? This is a variable and this is integer. So integer is what? Integer equals to 4 bytes. And this equals to what? 32 bits. Now, what if I need to design a system that doesn't require this number of bits? What will I do? I have to set boundaries to my data. And the only way I can achieve that is, one of the way I can achieve that is using the concept of what? Bit fields. So that is what I want to show you. So in this class, let's write a program that will receive information from what? A sensor in the farm. So the sensor will tell us weather condition. The sensor will be on, and the sensor will tell us the mode. So I'm going to write a program to illustrate that. If I do something like this, int a, then I say 3. So what I'm simply saying is, I want this variable a to only use 3 bits. That is what I'm saying. So if the variable is going to access only 3 bits, that will be what? 2 raised power 3. And that will give me 0 to what? To 7, meaning 8. 8 values. I'll be able to pull out 8 values from this. So that is how the concept of bit field is going to be used in this program. So let's write a simple program to illustrate that. Now, I told you I'm going to write a program for sensor. So I want my sensor to give me power, right? I want power. And power will be what? Either 0 or 1. And I want it to give me signal. So just like the bar on your wireless on your phone. So I want it to give me maybe 0 to what? 0 to 7. To 7 bar. So it will be something like this, right? I want that. Then I want the mode. So in this mode, I will either have 0 to give me what? Sleep mode. Then I will have 1 to be what? Active. Then I have 2 to be what? Maybe calibration. Then I have 3 to be what? Error mode. So these are what? How many values? 1, 2, 3, 4. Now, what will I use here? That means I will need 2 bits. Because 2 bits will give me 2 raised power 2. That will give me 4. So, we are using the binary number system in the machine language. Eventually, everything will be converted to 0 and 1. So that's what I'm doing using binary. So 2 raised power 4 will give us 4 values. So that means I need only 2 bits. So for this signal, to achieve this, I need 3 bits. So to achieve this, I need 3 bits. 3. Then to achieve this, I need just 1 bit. 1. Because this will give me 2 raised power 1. That will give me 2 values. So 0 and 1. Why this one will be what? 2 raised power 3. That will give me 8. So 0 to 7. So let's write a program to illustrate that concept. So I have something like this. I have include stdio.h, my library function. Then I'm going to create a structure. So struct, using my struct keyword. Struct, I will call it um, let's call it sensor status. Right? Sensor status. Now inside this my struct, I will use unsigned unsigned int, meaning it's not going to be, I don't need negative values. So if I just declare integer, it could give me negative or positive values. But with unsigned means I don't need negative values. It's just positive values that I need. So I'll call this power. Now this power, I'm just giving 1 bit. So I need just 1 bit. Then unsigned int signal. I need 3 bits for it. Unsigned int mode. I need just 2 bits for it. Now, if I didn't do this, integer is 4 bytes, 4 bytes, 4 bytes. That is what? 12 bytes. And each of them is what? 32 bits. That would have meant 96 bits. But with this, I am using only 1 bit, 3 bits, 2 bits. This is just 6 bits. So you can imagine using only 6 bits to achieve what I want to do. And then I still have 90 bits left. What I can do with that 90 bits. So that is the concept of this bit field and why it is very powerful. So I'm going to close this. So now I am going to write, I'm going to declare a variable for this struct. You know, it's a type and it's a structure. So I will do that in my main, int main function. Inside this my main, I will declare the variable for this struct. I will say struct sensor status. So let's call it sensor. So this is my variable, right, for this structure. Now I'm going to use this variable to access these parameters that are inside the structure. So for this power, I will say sensor dot power, and I will supply value 1 to it. Then sensor dot signal, I will supply 5 to it. Sensor dot mode, I will supply 2 to it. Now inside this, I will say printf power equals to percentage u for unsigned slash n signal equals to percentage u slash n, then mode equals to percentage u slash n, then comma. What should be there? I'm going to write it here. So for this power, this expression will require sensor dot power, comma. For this signal, sensor dot signal, comma. For this mode, sensor dot mode. Right? Then I'll close this. I'll close this. Now here I'll say return 0. Then I'll close this. So this is my program. What would this program do? So this is my input signal coming from the sensor in the farm. So power is 1. So with this 1, this is what will happen. Now I'm going to draw something here. So I'll do this. I'll do this. This is how it to be stored in the memory. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. All right. So I'll call this bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 5, bit 6, bit 7. So 0 to 7, that is 8 bits. Now, for this first one, this one will be what? Power, which is P. Then this one will be, so I need 1 bit for power, 3 bits for signal. So S0, S1, S2. Then I need 2 bits for mode. So mode 0, mode 1. So I have this bit and this bit free, reserved. So nothing is here, nothing is here. Now I'm supplying power as 1. So power being 1, in this power, which is 1 bit, it gave me 2 raised power 1. That would be what? 2 values. That would be 0 and 1. For this one is 2 raised power 3. That would be what? 8. So that would be 0 to what? 7. While for this one is 2 raised power 2. That would be what? 4. That would be 0 to what? 3. Right? So that is what I have. Now, since I have supplied 1 here, it means this place will be what? 1. Then I am supplying 5. If you convert 5 to binary, it will give us what? 101. So 5. Let's use red. 2 go into 5, 2. Remainder what? 1. 2 go into 2, 1. Remainder what? 0. 2 go into what? 1. Remainder what? 1. So this 101. So this will give me 1, 0, 1. That is how it's going to store this 5 in the memory. Right? Then mode, I supply 2 to it. So this 2, when you convert it to binary, is what? 1, 0. So you have 0, 1 here. Now this is how the bit has come. The 6 bit that is coming in based on what I have supplied here. So this value, this sensor is using this blueprint to insert this value into the memory. Now, the processor that is going to read this value will use this template to interpret what they mean. So since power equals to 1, that means on. It means my sensor is on. Then I have 3 bits, so it will read S1, S0, S1, S2, 101. It's converting this back to decimal. So that will be what? 5. So the signal strength will be what? 5. So that will be 1, 2, 3, 4, 5, like that, signal strength. Then for the mode, 01, that is 10. So it's reading it because this is what? Least significant bits. Then most significant bit. Now, P is on. Then this one is giving me 5 bit, 5 value, that is giving me this signal. Then for the mode will give me 2. So if I have calibrated 2 to be what? Like if I have designed 2 to be what? Calibration, it will tell me what it is. So coming here, I'm going to print out these values. This is a string literal with an expression. This expression is going to sense this value in the memory. This one tells me how I'm going to interpret the bit that I will see. That is unsigned integer. So power will give me what? 1. Sensor will give me 5. And sensor signal will give me 5. Sensor mode will give me 2 to print this out on the screen. So this will be the various signals. So this one will be what? Calibration. So this is how you are going to achieve this input using this concept of bit feed. So I've only used 1 byte. This is just 1 byte. Just 1 byte, which is what? 8 bit. And I've saved 90 bit because this will have been 4 byte, 4 byte, 4 byte, 12 byte multiplied by the bit. 32 bit, 32 bit, 32 bit. That would have been what? 96 bit. But I've only used 6 bits out of the 96 bits, and I still have 90 bit reserved. So that is the beauty of what bit feeds, right? So that's what I want to show you in this class. Let's go to code blocks and let me demonstrate this for you to see. So these are code blocks on bit fields, just as I demonstrated on the board. So I have my struct sensor status, and then unsigned int for power, unsigned int for signal, and unsigned int for mode. Power is taking 1 bit, signal is taking 3 bits, and mode is taking 2 bits. So this will tell you the values that those addresses can occupy. Then in the main, we create a variable which is called sensor. So this sensor, we are now supplying values to what? To power, to signal, and to mode. And I've explained to you how this will be stored in the memory. So we are printing out the value. So let's demonstrate this, run this script for you to see the output. Okay, so that is it. Power is 1, signal is 5, and mode is 2. So meaning the sensor is on, and then to show you the strength of the signal. Now, this is what I want you to see. If I change this place to 8, it will give you, the value will be 0. Because if you convert 8 to binary, that will be 4 bits. Whereas um, in this blueprint, we have instructed that signal can only take 3 bits. So 8 will be converted to 4 bits, so it cannot go. So it will round it up to 0. It's not going to give you any value, right? So let's run it and see what it will be. So can you see? So signal is what? 0. Because you are supplying 8, and 8, when you convert it to binary, is more than 3 bits. Is 4 bits. 1, 0, 0, 0. So that is why it's going to give you that. If I change this place to 4, it will also give me 0. So you see, because 4 is giving you more than 2 bits. That is why it's like that. So if I change it to 3, what will be the output? So you see, it's giving you 3. Because 3 is just what? Just 2 bits. 1, 1. So that is what I want to show you in this class. So to see in the next class. Bye-bye.